Welcome back to my channel Kishore Sarchi Pathshala. We are doing chapter Chemical Reaction and Equation 10 Cbse. Last time we have seen what is a combination reaction. Let's continue with other type of reaction. Today we are going to see a reaction which is nothing but is decomposition reaction. What we understand by decomposition reaction. So we have seen that vegetable waste decomposes, right? Okay, so that example we have seen last time. Now let's see today what we understand by a decomposition reaction. Let us take one activity. Okay, what we need to do, we need to take 2 grams of ferrous sulfate crystals in a dry boiling tube. Okay, right, we need to take a test tube. Okay, in that we need to take what? We need to take ferrous sulfate crystals. We need to take, and we need to note down its color. If you see the color of the ferrous sulfate is what? It is green in color. It is greenish in color. Okay. So what we need to do? Heat the boiling tube over the flame of the burner or a spirit lamp as shown in the figure. Right. You'll see that we need to heat it like this. Okay. So what precautions we need to take? Do not point the mouth of the boiling tube at your neighbors or yourself, right? Need to take this precaution. Okay, don't face this opening of the tube directly. All right. Okay, observe the color of the crystals after heating. You need to heat it, and what will happen? Some gases will come out. Okay, right. And what will happen? There will be change in the color, right? So this is the correct way of heating a boiling tube containing crystals of ferrous sulfate and smelling the odor, right? Okay, need not smell it directly. Okay, so this is how we need to do the experiment for this. Now let's see how the experiment goes about. Now what happens is that if you see here ferrous sulfate, right, ferrous sulfate, that is my FeSO4. What will happen with FeSO4? FeSO4, when we heat FeSO4, right, it decomposes into what? It decomposes into ferric oxide, then it decomposes into sulfur dioxide and sulfur trioxide. So ferrous sulfate crystals, okay, these are the ferrous sulfate crystals. Water of crystallization is there. Lose water when heated and the color of the crystal changes. So we have seen that this is what? This is green in color, right, greenish in color, and it decomposes to ferric oxide, right. Ferric oxide, if you see, is what? It's solid and is brownish in color, right. So color change from green to brownish is the color change. Okay, then which gases comes out with that? We get sulfur dioxide and sulfur trioxide gas we get. Okay, these two gases also we get along with this. A single reactant breaks down to give a simpler product. So this is a decomposition reaction, right? So what is happening is there, you'll see that a single reactant is there. So it is breaking down in more than one product. Here you see. Okay. So this is my decomposition reaction. So decomposition reactions are of different types. Let's see those. First, let us talk about the thermal decomposition. What we understand by thermal. Thermal means what? Heat. Okay. When something is heated, so that means thermal. So let's talk about thermal decomposition. So let's take a simple example of calcium carbonate. What we need to do, we need to take a hard glass test tube, and in that test tube, what we need to do, we need to take calcium carbonate and we need to heat this test tube, okay, right, by burner. So what we'll be getting is that when we heat calcium carbonate, we'll be getting calcium oxide and carbon dioxide gas is released. So carbon dioxide gas comes out of this, right? So carbon dioxide gas is released, right? So what we are getting, see, calcium carbon dioxide, calcium carbonate decomposes into calcium oxide and carbon dioxide, right? So this reaction is carried out by heating, therefore it is called as thermal decomposition. So decomposition reaction of lead nitrate, let's talk about this. Again, a example what we are taking. What we are doing is we are taking lead nitrate, right, in a boiling tube, and we'll observe what brown fumes which are coming out, right? So these fumes are nothing but of nitrogen dioxide, right? This is how the reaction takes place. We have the lead nitrate which is in solid state. When we heat this, we get lead oxide, then we get nitrogen dioxide, and then we get oxygen, right? So a single reactant is there. Okay, on heating it, we are getting C3 products, right? Now let us see electrolytic decomposition. Okay, a decomposition which is called as electrolytic decomposition. What is electrolytic decomposition? It is nothing but when you pass an electric current, right? When you pass an electric current through the solution, and when the decomposition happens, that time it is what? Electrolytic decomposition, right? So what we have water, right? And that decomposes into what? Hydrogen and oxygen, right? So water decomposes into hydrogen and oxygen. Okay, so in electrolysis of water, what we are saying is that this is the apparatus. Okay, we are taking a plastic mug, and here you are, what you are doing here, putting the graphite rods inside. Okay, and you are connecting one of them with a anode, and another is called as a cathode, connecting with a battery, right? Okay, one is called as anode and another is cathode. Anode, as we all know, is positively charged, cathode is negatively charged. Then what we are doing, we are putting a water inside, right? Okay, and after that what we are doing, pure water is a very poor conductor of electricity. Why? Because it lacks ions and only contains molecules. So what we are doing, we are adding little sulfuric acid to it. What happens when sulfuric acid is added? It ionizes water, right, to release what? H plus ions, right, and HSO4 ions, so which conducts the electricity. And what happens is this increases the number of ions in the solution. Okay, so number of ions will increase, and thereby it makes it a better conductor, right? Then you see the apparatus is like this. We need to start the electric circuit, electric current. Okay, then what will happen in the two test tube? You will see bubbles will be formed, right? Bubbles will be formed, and here you will see that oxygen and hydrogens have been collected in the test tubes like this, right? But see, the volume of the gas collected in one test tube is double, right, the volume of gas collected in another, because water is made up of two parts. It is made up of hydrogen and it is made up of oxygen, right? Okay, hydrogen is how many parts? It's two parts of hydrogen, right, and a one part of oxygen. Okay, right. So we are collecting these two gases. Oxygen is collected at anode, hydrogen is collected at cathode. So if we bring a burning candle, okay, near the mouth of a test tube which contains hydrogen, so what we'll get? We'll get a pop sound, right? We'll get a pop sound is observed. And if we bring the burning candle near the mouth of oxygen tube, what will happen? The flame increases. As oxygen supports combustion, the flame increases in that case. So this is my electrolytic decomposition of water. Now let's talk about a photolytic decomposition. Now photolytic itself means what? Photolytic means the decomposition which takes place in presence of sunlight. Okay, it takes in presence of sunlight, right? So that is my photolytic decomposition. If we see silver chloride, white silver chloride, it turns gray in sunlight, right? This is because of decomposition of silver chloride into silver and chlorine gases released. See here, sunlight is there, right? This is my photolytic decomposition. Same way, if you see that silver bromide, right? If you take silver bromide, it also decomposes into silver and bromine, right? So what we understand by a photolytic decomposition, let's see. When a decomposition reaction requires energy either in the form of light, okay, right? So that is my photolytic decomposition. So that is the sunlight. In the presence of sunlight, that decomposition takes place. For example, here you'll see we have a silver chloride which turns gray in sunlight, right? This is because the decomposition of silver chloride happens in presence of light, okay, into silver and chlorine gases released. Same way, if you see silver bromide, it also decomposes into silver and bromine. The above reaction are used in black and white photography, that we need to remember. So the decomposition reaction requires either the form of heat, light or electricity for breaking down the bonds. Okay, breaking down the reactants. So this reaction where energy is absorbed is also known as endothermic reaction. Okay, so endothermic reaction is nothing but where energy is required to break the bonds of what? Reactants, right? Where energy is supplied. So this is the energy supplied. So last we have seen the thermal, also we have seen electrolytic also, where electric energy was required, right? We have seen the thermal decomposition also, where you require heating. So all these things we require what? We require some energy. Okay, so that is my endothermic reaction. So students, I'm sure you have understood today's topic of decomposition and different type of decomposition reaction. Kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.